Welcome to Developer Service YouTube channel. On today's video, we're going to be discussing file monitoring in Python and concretely how to monitor files with Watchdog library. So the Watchdog library is a library that provides a very simple API to monitor both directories or specific files for changes. Let's see how it works, the Watchdog. So we have the Watchdog library. We initially set up observers, which are responsible for the initialization and monitoring. Then we set up schedulers, where we define the path, which can be a directory or a file, and recursive monitoring or not, in case it is directories and subdirectories. So observers, schedulers, and then the events are handled by event handlers, which can be the onCreate, onDeleted, onModified, or onMove. And normally, we manage those events through custom subclasses. So let's now take a look at some code examples. I have 4 examples for us to take a look at. So let's take a look at the first code example. Of course, we start by importing the necessary libraries from Watchdog. In this case, the observer and the file system handler, which allows to monitor changes in the file system. And we start by creating our subclass. That subclass the file system handler, like I mentioned before in the diagram. We normally handle the events with subclasses. In this case, we have a class myHandler, which subclass from file system event handler, and is handling the onModified, onCreated, and onDeleted events. These are events that are launched by the file system event handler. We're checking if it is, in this case, if it is not a directory, then we're going to show modified, or if any file has been created or directory it has been created or deleted. So we can receive the event and we can check if the event is a directory or a file, and we can also do logic according to that. So this is how we set up the custom class, how we set up the observer and the schedule. So we start by defining the path that we want. We create an instance of our handler, our custom subclass. We create an instance of the observer, and then we schedule the observer. Of course, the observer is going to use that handler, that custom subclass. The path that it's going to be monitoring is the path that we define here. And of course, we can define if it's recursive or not in case of a directory, if it goes through the subdirectories. In this case, I'm saying false. And we start the observer. So in order to monitor, the script needs to be active. And for that, we're building in a while loop, while true. So it continues indefinitely. We're doing a time sleep to keep the script active. We're surrounded by a try and accept catch, so that we can stop the observer when we do the Control-C, for instance, and stop the execution of the script. And after everything has run and we stop the script from running, the observer join, so that the thread that has been started by the observer start can also be stopped in the script, and both the thread can stop without any problems. So if I run the script, we can see it's monitoring, in this case, the directory where the source code is also are. So if I save any change in the source code, you see it has been modified. It launches due to the way that the file handling works, and also due to the way that the ID creates the file changes. But if I create a new file, you can see that I can write a new file here. It's going to say that I've created a new file. So that's how the file server observer work for one directory in specific. Another example that I wanted to show is how to handle multiple directories. In this case, we have the same. We're doing the imports. We're subclassing the file system handler as usual with the class myHandler. In this case, we are using another of the keywords, which is on any event. In the previous script, we had differences for onModified, onCreated, or onDelete. In this case, for this script, any type of event is going to be launched. We can also get the event type from the event, and then event type. We can capitalize it to show it in capital letters, and the path that has occurred. We're creating a function to help us monitor the different directories. So it will receive a list of directories, and it does the same that we saw in the previous script. It creates an instance of the handler, of the observer. Then for each of the directories, it sets up the schedule with that particular path, and for that handler, for that particular path. In this case, we're going to do recursive, and we start the observer. We do the same for each of we do the same when setting up the directories to monitor. We do the while true loop, we sleep the time, and then we do the observer stop and the observer join to stop all the threads from running. And of course, we executed by we set up the directories to monitor, which is a list of directories. and we call the monitor directories with this list of directories. So if I run the script, it's now running, and you can see if I change this file, it's going to print the event in the file path that has been modified. You can see the difference. For instance, if I remove the capitalize and I execute the script again and I change the file, now it says modified with a lowercase. So that's what the capitalizer does. For the third example that I would like to show, I'll show how you can also add the logging to the file system monitoring. So we have our standard imports, where initialize in this case we're also additionally imported logging. When setting up the basic config of our logging, we're saying that we want to log the info with a specific format which shows the time, the level name, and the message. We're again creating our custom subclass filter handler, in this case from file system handler. We're doing the unmodified, uncreated, and undeleted events. We're checking if it is not a directory. In this case, we're also filtering if the specific file ends with .txt, so we're looking for only checking the events for file text files. So we're going to be showing if the showing in the log if it has been modified the text file, or if we have created a new text file, or if we have deleted the text file. We again set up a function to monitor a specific path. We'll receive the path in recursive or not. We're setting up our handler with the custom subclass, our observer. We do our schedule, assign the handler, the path, the recursive, and we start. And we do the same while through loop, and we stop the observer and we join for the threads. And of course, we call this by calling monitor path. We pass a specific path. In this case, we're going to see that it's also recursive. So if I run this, and you see if I change, for instance, now the code file, I'm changing it, and see, does not show up as modified because we're only interested in text files. Even if I create a new file, so I can create a new file, it does not show up. But if I create a new file that ends in .txt, which is a text file, we can see that it shows up in the logging with the format that is specified, and that we have created a new text file in this particular directory. So that's how we can do logging and also filter by specific event or a specific file type in this case. Then the last example that I wanted to show you, it's in terms of when you have a lot of changes in the file system and you don't want to have a lot of events being launched and handled by your event handler and by your script or application. So we import our observers, import our time, our logging. In this case, we're importing timer also from threading because we want to be debouncing with a debounce timer. Very simultaneous requests that can happen. So I set up our basic logging as before, as in the previous script, where it's a classing again with our debounce handler from file system handler. In this case, we're also performing the initialization because we are going to be starting our timer instance or preparing the variable for our timer instance. We're going to be using the on-end event, so it does not matter if it has been created, modified, or deleted. And on that event, we're first checking if we have an instance of the timer running. If we already have an instance of the timer, we are going to be cancel that instance. If not, then we're going to be creating a new timer that will be launching in 1 second, and it will handle the event with the handle event function that we'll see next, and it will pass as arguments the event that is also part of the file handling. And we start this timer. When the timer fires, we handle the event, and the same as before, we're logging what kind of event happened to its specific file has happened. We also have a function where we initialize everything, where we monitor path with events, and receives our path and recursive or not. We do the handler, the observer, schedule, and we start, and we do our loop, get stop and join. And of course, we call this with the monitor path with events. We pass a specific path and recursive true. So we run this script, and as before, it's filtering the text files. So if I go to the text file and I perform some changes, and it will take a bit of time. And as you see, if I'm performing a lot of changes, it is not showing them simultaneously. It's taking a while. That's 1 second. And why does that happen? That happens because of how we define the debouncing. So if simultaneous events are being launched, that means that this timer, that the first event will manage to create a timer because there is no timer. When the first event comes, it will create a timer that will be fired after 1 second. But if some simultaneous events are being posted, then that means that the timer, there's always an existing timer that is always going to be cancelled. So this is a way to debounce the very several simultaneous events that are being launched, and only the last event will be able to call the timer, because only the last event will be successfully elapsed after 1 second. So that's how we can debounce successive events and only handle the last event in terms of the processing. If you'd like a bit more information about the Watchdog library, you can also check the article on the developer servers blog. The link will be in the description. Like this video if you like this content, subscribe for more content about Python, Django, and AI. And until next time, happy coding!